Hello friends, this is Jim with Science Talk. I want to talk with you today about permafrost. Now I just made a video where I talked about permafrost thawing and some of the ramifications about that. And I've mentioned permafrost before in some of my other videos. But I wanted to devote this video to describe for you what permafrost really is for those who are unaware of what permafrost. The general definition is permafrost is permanently frozen ground. Now, there are different types of permafrost, and I'll get to that in a moment. So basically this means is you have ground that's permanently frozen. Now there may be cases, and lots of times this is the situation, where the upper layers, maybe the upper 10, 20, perhaps 30 centimeters or so, will thaw out during the summertime when there is well over 20 hours of daylight and the air is warming up and so forth. How far down the permafrost goes is pretty much a function of a couple of things. One being latitude, the second being how far inland is the area under consideration. The more interior, the more the likely of the ground being frozen to greater depths, as is the higher in latitude that one goes, the more likely the permafrost will be found to greater depths. And also, if you have a mountainous area as well, as you go up in altitude, you will also have permafrost. And again, how far deep it reaches is a function of several things. We can actually see this when it comes to, say, mountains, that the south side of a mountain tends to have less permafrost. For obvious reasons. The sun is able to reach directly, whereas the north side, where the sun doesn't reach as often, or with the heat intensity, basically measured in watts per square meter, then the ground is more likely to be frozen. How deep does the permafrost go? Well, again, depends on where you're at. It can be from a couple of meters to hundreds of meters deep. So now we talk about that it's more appropriate to say the permafrost is thawing. We don't say the permafrost is melting. Here's why. Melting refers to a change of state, going from a solid to a liquid. Thawing simply refers to the state of going from frozen to not being frozen. Let me give you an example. Let's say you go into your freezer and you pull out a block of ice and some frozen meat. And you set it out on your table at room temperature. What happens? The block of ice turns to liquid. It melts. It's change of state. Right? Solid to liquid. The meat simply thaws out. It's no longer frozen. It's still in the solid state. It's just now no longer frozen. That's why it's more appropriate and more technically precise and correct to refer to the permafrost as thawing. Now, the different types of permafrost. This is going to depend on the substrate, on the ground that's underneath. If you've got a pile of rocks, gravels, and so forth, and that ground is frozen, what you get is what we call thaw stable. Meaning that if this ground were to thaw out, you would still have a pile of rocks and gravel. It's just no longer frozen. Contrast that with thaw unstable. This is where we can get into headaches. And I'll get to that in a moment. Thaw unstable is basically frozen silt. Silt that's typically loess, to use the more accurate German term, and it's just silt, it's clay, and it's frozen. And when that thaws out, there's a interesting thing that happens. It's called liquefaction. And basically, the ground turns to goo. Now there's a technical term. Right? The ground turns to goo, and it just slumps and slides and moves all over the place. Why does that happen? Because as it's thawing, there is a water moisture content in the soil that basically helps turn it into a mud. Just think of when you grab a pile of topsoil and you put a bunch of water in there. It gets kind of muddy, right? How many of you used to make mud pies when you were kids? It's sort of the same idea. Now this has serious consequences, because if you're building homes and roads and that kind of stuff, and you are trying to build over thaw unstable ground, and the ground decides to thaw out, uh-oh. You will see the road starting to buckle, the building starts sinking and twisting, and all sorts of lovely, no sarcasm, things will take place. So there are different types of permafrost, different types of situations. The thaw unstable is the one that gives engineers headaches. As an example, the Trans-Alaska Pipeline. It stretches 800 miles, approximately, from Prudhoe Bay on the north slope of Alaska, all the way down to Valdez in Prince William Sound. And over the course of this 800-mile journey, it traverses so many different ecosystems. It crosses rivers, goes over mountains, and so on. Approximately half of the pipeline is visible above ground. Half of it is buried. It should not come as a surprise that the portion that is buried in the thaw stable ground. Because when you're running oil through the pipeline, the oil is hot. Now yes, they insulate the pipe and so on, but there's still heat that's given off, and that heat will thaw the surrounding ground. So if you try to bury the pipeline in thaw unstable ground, the ground's going to start shifting, so on and so forth. The pipe could actually split, and then you have a catastrophe on your hands. So the portions that we see above ground, the ground underneath there is thaw unstable. And you've probably seen the photos. They have, you're sitting on some pylons, and these are like what appears to be brackets. They're actually shoes that the pipeline itself sits on. The pylons, depending on the situation, sometimes are driven 100 feet or so into the ground to try and get it past the critical layer of the permafrost. And then you'll notice, you probably see some fins on top. The fins are actually, because the ground in the winter time is warmer than the surrounding air, you want to take the heat, remove the heat from the ground during the winter time and dump it out into the atmosphere. Alyeska will fly helicopters up and down the pipeline with infrared sensors, and they will just look for the infrared signal from each of these fins, and if they don't get a signal, then they know it needs maintenance. But the point is, you want to keep the ground frozen. You do not want it to thaw out, because if it thaws out, it becomes unstable. We don't want that. Now, as far as sitting on the shoes, the pipeline is designed to slide back and forth in the event of earthquakes. So there is some flexibility. This is why you see it's not a straight shot. There's zigzags and bends and so on. That's allowed for expansion, contraction, as well as any shifts due to earthquake activity. That's a whole nother situation. So with permafrost, now let's go back to what I've been discussing with the permafrost. As it starts to thaw out, vegetative matter will start decaying. You start releasing methane, carbon dioxide. These are greenhouse gases. And as I described before, in other videos, you set up a positive feedback system. Release greenhouse gases into the air. They trap the long wave radiation. That traps the heat. The heat warms up the ground, further thawing the ground, further accelerating any decomposition, further accelerating the release of methane and carbon dioxide, and so on and so forth. So, and as I said before, this is the question that has a lot of climate scientists. This is what keeps them up at night. So, how do you know what kind of ground you've got, whether the permafrost is thaw stable or thaw unstable? Typically, you got to take a core. But the problem with that is when you take the core, you now have removed a bit of ground, and now the air can get in there. So, in attempting to identify the ground you have, you could actually be creating a problem by allowing for the ground to start to thaw out. Also, permafrost can be discontinuous or continuous. And those words should be self-explanatory. Discontinuous is that you might have a ribbon of ground here that's permanently frozen, and over here it's fine. And likewise, over here is another patch of frozen ground, another patch that's fine, not frozen. Continuous, everything underneath is frozen. Typically speaking, north of the Yukon River, the permafrost, for the most part, is continuous. And we start seeing the tundra. And you can also tell by the vegetation. If you have permanently frozen ground, the only plants that can really establish roots are tundra plants. They don't need to have a deep root system, such as, say, willows and trees do. But you can be out on the open tundra, it's continuous permafrost, and then off in the distance you see what looks like a line of willow bushes, perhaps even some small trees. And by small trees, we're not necessarily talking about black spruce. They could be there. Black spruce are typical, that's the taiga, and that's typical of growing in acidic soil with a permafrost where the frozen ground starts a little deeper so that the black spruce can set up their roots. But when you see in the distance willows, the transition from tundra plants to willows, chances are extremely high that there's a creek there, some sort of water zone. We call such areas riparian zones. And this is sort of like an oasis. Animals can come here and so on. So, you can tell a lot by looking at the surrounding. And here's another example of climate change in action. There is documentation of an area, several areas, photos of the exact same location taken 50 years apart. And in the photos from 50 years ago, we see tundra vegetation. Photos taken 50 years on, more recently, the tundra vegetation has been replaced by low-growing bushes, like willows. Which means what? The ground is thawing such that willows, which require a deeper root system than tundra plant, are able to get established. They're able to set up the deeper root systems. So with that, we see changes in not only the flora, but also the accompanying fauna. Further evidence of things warming up. So basically, to quickly recap, you have thaw stable, thaw unstable. You have continuous, discontinuous. Permafrost can range in depth from a couple of meters to hundreds of meters or more. Factors that determine where it's found and how deep it goes are latitude, altitude, distance from the ocean, from any large body of water. So basically, the more interior it is, the deeper will be the permafrost. And of course, if we have Thaw Stable, it's basically a conglomerate of rocks and pebbles, gravel, and that kind of stuff. The Thaw Unstable is pretty much frozen silt, frozen clay, so that when it thaws, it liquefies. It's liquefaction is the process, and it just becomes gooey and so on. So I hope you found this informative, and just to kind of give you a handle of the different kinds of ground situations you might encounter. So if you like this video, please share this video. Please subscribe to my channel. Please inform others of the work I do. I hope you will consider becoming a patron and support the work I do. The information I put in these videos I consider to be of great importance that needs to be disseminated to a large body of people so that people know what is happening with our planet. If you're already a patron, I thank you for your support. You can go to patreon.com/Science Talk with Jim Massa and subscribe for a very nominal monthly rate of $3 or more if you're so inclined. Thank you for your time.